Hello, discrete math fans. Let's prove that if we take a rational number and an irrational number and add them together, that we'll get an irrational number. Now we should take note that the statement that we were given has an implicit universal quantification. It's saying something about all rational numbers and all irrational numbers. All right, let's rewrite this statement in formal logic. Now along the way, I'm going to use this symbol. This is a blackboard bold I to represent the set of irrational numbers. Now I may use this from time to time in this class, but I would really caution you that this is not standard terminology, and you should not necessarily expect that people outside of this class would know what you mean if you use this symbol to represent the irrational numbers. All right, so when we rewrite it in formal logic, it looks like this. For all r in the rationals, for all s in the irrationals, the sum of those, r plus s, is irrational. If we negate this statement, we'll get something that looks like this. All those universal quantifiers turn into existential ones, and then we have to negate the inside. So now it looks like there exists r in the rationals, there exists s in the irrationals, such that r plus s is rational. Remember that the original inside statement was that r plus s is irrational, so when we negate it, we get r plus s is rational. All right, we're ready for the proof now. So let's suppose, for the sake of contradiction, that there is a rational number r and an irrational number s, so that the sum r plus s is a rational number, and we'll call it t. Note what we're doing. We're supposing the truth of the negation of the original sentence. We're going to use this now to arrive at an impossibility or an absurdity or a contradiction. All right, so r is rational. What does that mean? That means there exist integers a and b where b is not equal to 0, such that r is equal to a over b. And in a similar way, since t is rational, there exist integers c and d with d not equal to 0, such that t is equal to c over d. Remember that t is the sum of r and s. All right, if we do a little bit of arithmetic here and just compute what s is r plus s minus r. But what was r plus s? That was t. So s is really t minus r. And then if we replace everything with the a, b, c, and d that we got before, we can end up with an expression that looks like this: bc minus ad all over bd. And remember that b was not equal to 0 and d was not equal to 0. That tells us that the denominator that we've come up with here, that's not equal to 0. Also, bc minus ad is an integer, as well as bd is an integer, and that tells us that s is a rational number. And that contradicts our assumption that s is an irrational number. You can't be rational and irrational at the same time. And that proves it now, that the sum of a rational number and an irrational number is irrational. Okay, that's all for now.